device. Those are online. Am I audible?
Yes, sir.
Yeah, keep revising the previous class topics. Okay. Can we get started? எனக்கு இன்னொரு புக் 2 waste பண்றதா கிழிஞ்சிருச்சுல இதுதான் கிழிஞ்சிருச்சுல பார்க்கலாம் அதை வச்சு பண்ண முடியும் வைஃபை வரையும் அவ்வளோ okay. See, till now we discussed about the different kinds of reactions and different kinds of actions and reactions, if you remember, right? So we saw what is force, what are the different. See, I cannot speak loud. If my voice is not audible, let me know. Especially people at the back. We saw about the different kinds of forces and we solved some problems based on free body diagrams also, if you remember, right? So for all those cases, if you observe, let's say if you considered an inclined plane or any surface, a flat surface, everywhere we considered it to be frictionless, right? Everything was a smooth surface. Ideally, nothing can be smooth, but for the sake of solving problems, we try to understand what happens when there is a smooth surface, right? So the next part of this chapter that we need to understand is what is friction, right? So the next topic, friction, right? So the question is, what is friction? What is friction according to you? So what do you know about friction? You would have learned about it in your lower grades, right? So to those who are online, am I audible? Is my voice clear?
Yes, sir.
Yes,
Okay.
sir.
So even you can answer. Okay. Force acting in the direction opposite to the motion. That is what is friction, right? Okay. Any other answers that I can have? So I feel it is always important that you visualize before you start learning some science behind it, right? So can you try to give me an explanation? He told that if there is an object moving, there is going to be a force in the opposite direction, which is called as friction, right? Is there a better way that we can understand? Let's do a very simple activity that you know. See, you take your 2 hands, keep your palms together, just rub it. Okay, if you do it like this, and if you do it faster, right? Tell me what is it you're able to sense. Just try to do and see. Do it slow. Don't give so much of pressure. Just keep it like this. And are you able to sense any heat? You're doing it like this. I'm not applying any pressure. You're doing it like this smoothly. Okay. Are you able to sense any heat? Now apply some pressure, right? Do what I say. Apply some pressure and try to rub one against the other. What are all the differences that you observed in this? What are all the differences you observed in both the scenarios? So in the first case, when you didn't apply pressure, you tried to rub one against the other. What happened? First thing, you couldn't sense any heat, right? And your hands were actually moving faster compared to each other, right? So there was a relative motion existing, means the motion of this hand with respect to this and the vice versa was existing, where you could move the hands faster. Whereas when you tried to hold them tight like this, right? When you try to hold them tight and try to rub it, you can observe that there is some resistance to the motion. What kind of a motion? It is not resistance experienced only by one hand. it is a resistance experienced by the other hand also. So there is a resistance being offered not to the specific motion, but rather it is to the related motion. Are you able to understand what do I mean by relative? Motion of one with respect to another. So there is a resistance offered to the relative motion, right? When they are pressed together and you try to move them. At the same time, you would also sense heat getting generated faster. Okay, why is it happening? Because the energy is getting lost. There is, when you're doing this, no, you're doing some work. So energy is getting lost in the form of heat. And who is making that energy to get lost? It is friction, right? So there is an important point that I want you all to understand. This is something with respect to hands that we did. Now, let's take two books. Okay, let's take these two books. I want somebody to come here. Hitesh, can I have you here? So what I want you to do is lock these pages together. So keep it like this. Okay. So like this, you can lock it. Lock it tight enough. Not everything, like you can take two. So you can release both of them simultaneously. I'll show you. It's loose enough actually, but let's try and see. Okay. So I've locked them. Right. So there is a possibility it might fail also. It depends on interlocking. Tell me one thing. You touch these papers, no? So how are these papers? Are they smooth or rough enough? Is it smooth? So compared to that paper, it's rough, no? Okay. So what is rough according to you? Like, see, what is the difference? You take this paper. Can I have that book? I want to show it to others. So you have a branded book, Classmate. Okay. So where you have some papers, it appears to be smooth. When you write on this also, you can sense it. You touch it, you're able to sense. See, right? Compared to this and this, what do you mean by roughness? Kind of pores. Can I say there are more number of pores existing? So when I take these two papers and I interlock them like this, when you try to pull them, what do you think will happen? We are trying actually. We are not cheating, okay? So come here, come here. I let everybody see. So if you observe, we are trying it actually. The only option is book will tear. See, look at his face. There is actually a tug of war going on, right? So yeah, thank you. So what exactly did happen here? See, even now I'm not able to take it out. You can try and see. Somebody, if you think I'm cheating, you can try and see. Is it working? Why? See, it's okay. Simplest answer that you can give is friction. But the idea is to understand how that concept is working. That's the answer. So the answer is, if you see, I was stressing on one point again and again. What was it? Roughness of the surface, right? So what was actually happening here is when you were applying the force, there is a pulling force applied in this direction and there was a pulling force applied in this direction also. When you try to apply them, right? When you try to apply them and pull them out, between the surfaces to this hand, when I'm trying to pull it like this, there is an opposing force acting in this direction. Similarly to this hand, which is trying to pull in the leftward direction, there is an opposing force in this direction, right? So that opposing force, which is actually stopping the relative motion between both the surfaces, is what is called as friction. I'm stressing on this point again and again. Friction will not act only for one surface. It is going to stop only the relative motion. Meaning, meaning this book is exerting a friction on this, and this book is also exerting a friction on this exactly in the opposite direction. Okay, so remember this point, you will understand when I'm solving the problems. Okay, this is one point which many people miss. So coming to the definition, whenever an object moves or tends to move, so there is an object already moving or it is tending to move, like when we try to pull, we were trying to put it in motion. tends to move over the surface of another object, there will be a force that comes into play, which will do what? Which acts parallel to the surface of contact and opposes the relative motion. Which opposes the relative motion, and this opposing force which stops the relative motion is what is called as friction. Am I clear with that? So having said this, we need to understand how exactly it is going to work. So if I take a fixed surface like this, so if I take an object of mass m1 placed on the surface, and let's say there is an object of mass m2 that is placed on this surface. Okay, are you able to understand? Right. Now the question is, let me consider the bottom surface to be smooth. What am I doing? I'm considering the bottom surface to be smooth. I am applying a force on this object. Which object? At the object which is present at the bottom. Can you describe what will happen to the motion of the system of M1 and M2 if this surface is rough? Okay. So if I ask you to draw a free body diagram, how will you draw it? For M1, if I ask you to draw a free body diagram, there is a force that is going to act in this direction, right? So this force. Now, what will be the forces that is acting at the point of contact of these two surfaces? Friction, right? So friction on M2 will act in which direction? Opposite to the thing is, if the force had been applied here, then it would have been opposite. This is the reason why I took this scenario into consideration. Okay. Now I'll do one thing. I'll just make it simple for you. Okay. So I'll come to the scenario later. I will just make the scenario simple. You tell me what will happen in this case. Okay. So let's start fresh. If this is the force that is applied where there is an object kept on a rough surface, can you tell me what will happen? Can you tell me what will happen here? If I ask you to draw the free body diagram, capital F is in this direction, M1, right? Now, this M1 is kept on a rough surface and this M1 is trying to move relative to that rough surface. So what will the rough surface try to do to this? Will it allow M1 to have a motion? It will try to stop. It might stop, it might not stop. That we don't know because I don't know the magnitude of the force and the magnitude of friction. Let us assume that there is a force that is going to come into picture due to whom? Due to the surface on M1. In which direction will it act? It will act in the leftward direction, which is going to be small f. So this is the meaning of friction will always come into play parallel to the surface of contact. Friction will always come into play parallel to the surface of contact. Did you understand this? Okay. Now the next question is, since the friction is acting on M1 due to the rough surface, what will this surface try to do? What will this surface try to do on the fixed surface? So on the fixed surface, if you observe, there will be a force of same value F, but this time it will act in this direction. So this is the important point which nobody mentions. Are you able to understand? So here there are two things that are going to happen. What is going to happen? Rough surface is offering a force to M1. At the same time, M1 is also offering a force on the rough surface. Okay. So the rough surface offers force on M1 in the direction opposite to the force experienced by M1, the external force experienced by M1 is in the rightward direction. So the friction will come in the leftward direction. But on the surface, on the rough surface itself, in which direction will the friction act? It will act exactly in the opposite direction. This is like an action-reaction pair. Exactly similar to what tension does. You remember when you take a string, tension at the bottom, if it is upward, top will be downward. I told you, no, it will be of the same magnitude, provided it's a massless and a inextensible string. In a similar way, when you talk about a rough surface, this is the most important point that you need to know. This everybody knows. Are you able to understand what is going to happen here? Now, this is how the free body diagram is going to look like. So having said this, let's first try to understand why is there a friction even coming when there is a rough surface. So when you talk about a rough surface, right, when you actually zoom and see, right, on a rough surface, if you're able to zoom and see, you will have something like this. This design is what is called as irregularity. So what do you call them as? You call them as the irregularities present on the surface. So when I talk about two rough surfaces coming in contact, right, there will be irregularities on the first rough surface. There will be irregularities on the second surface also. So what will happen when they are trying to move, they actually get interlocked. That is the reason why there is an opposition in the motion that is happening. So is the concept clear? Did you understand what is friction? Right? So what does friction do? It opposes the relative motion between two surfaces. Secondly, why is friction even coming into picture? It is because of the interlocking that is taking place between two rough surfaces. And thirdly, if you draw a free body diagram, how will the friction act? If friction due to one surface on the other is in the leftward direction, then the vice versa situation will be in the rightward direction, like how I showed it here. Is the point clear? So these are all the important points which you need to make a note. Please write it down. right? Yeah. So the next concept we'll see is static limiting and kinetic frictions. Listen to this carefully. If I take an object on a rough surface, and let's say there is a force that you're applying, F is equal to 1 Newton. Okay, where this surface which is rough, no? So the surface which is rough will be able to stop the object from going into motion till you apply a force of 5 Newton. So what is the meaning of this? This surface can offer a maximum resistance of 5 Newton, right? So when you apply a force of 1 Newton trying to pull that object on that surface, will it move? It will not move. But the next important question that you need to ask is, out of the 5 Newton, which is the maximum value that can come into picture, how many Newton will actually come into picture? It is not all 5 that is needed to stop that object. Out of the 5, 1 Newton is sufficient. So what I'm trying to say is, when you apply a force of 1 Newton, right? When you apply a force of 1 Newton, there will be a frictional force of 1 Newton exactly that will come into picture. If you increase this to 2 Newton, what will happen here? 2 Newton out of the 5 will come into picture. If you increase it to 3, 3 will come in picture. If you increase it to 4, 4 will come in picture. If you increase it to 5, what will happen? 5 will come into picture. Now, if you increase it to 6, it will still be 5 Newton that will come into picture. Even if you apply 5.1 or 5.000001, what will happen is it will still be able to exert only that 5 Newton, beyond which it cannot apply the resistance. Is that clear? So this kind of a frictional force that comes into play, so the force of friction which comes into play between two bodies before one object actually starts moving over the other is what is called as static friction. So what is it called as? Static friction, because what does static mean? Static means rest. So to put it simple, the frictional force that comes into play when the object is still at rest even before it starts moving is what is called as static friction. Then what is this limiting friction called as? This limiting friction is what this 5 Newton is. It is the maximum static friction that the surface can offer before the object actually goes into motion. So what is it? It is the maximum force of static friction which comes into play when a body just starts moving over the surface of another body. In this case, what is the limiting friction? In the example that I used, the limiting friction is 5 Newton. So if you observe between that 1 Newton to 5 Newton, right, what was happening? The static friction didn't come into picture as complete 5 Newton. When you apply the force of 1 Newton, there was only 1 Newton that was utilized from the limiting friction. 2 Newton, right? When you increased it to 3 Newton. So what was happening is the friction was adjusting itself based on the external force that we applied. That is why static friction is also called as self-adjusting force. So what is it called as? It is called as a self-adjusting force. So it will adjust itself till what value? Till that limiting value is attained. So just to conclude it, what is it? What does static friction mean? The frictional force that comes into picture just before one object starts sliding over the other. Right. What is the limiting friction? It is a maximum static friction. Yes. Imposed on another body before it just starts moving. Okay. When can it just start move? When there is an unbalanced force. When this force is going to be 5 point something greater than 5. Is that point clear? Right? I didn't get into the mathematical details. This is all about static and limiting alone. About kinetic, we'll see it next. Make a note of it. Will I proceed? Right? Okay. Now we'll see what are all the laws of limiting friction. Right? So these things are studied from experiments. From experimental study, the limiting friction is found to obey the following laws. The first thing is, of course, the limiting friction should depend on whom? The limiting friction depends on the nature of the surfaces in contact and their state of polish. Right? So if they are polished enough, what will happen? The limiting friction is going to decrease because it cannot offer more resistance. Right? Secondly, the limiting friction acts, this is an important point, it always acts tangential to the two surfaces that are in contact. And how will it act? It will act in a direction opposite to the direction of motion of an object. So it will always act in the direction opposite to the direction of motion of the object. And the third part is the value of limiting friction. This is an important point. The value of limiting friction is independent of the area of surface in contact. Okay. So as long as the normal reaction is going to remain the same. In the sense, if the surface, if the object you're trying to go pull is going to be placed like this or like this, the limiting friction is still going to be the same. As long as what? As long as the normal offered by the surface is going to be the same. Okay, that is another important point to be kept in your mind. And the limiting friction is directly proportional to whom? The limiting friction, that is Fs max, is directly proportional to the normal reaction R between the two surfaces. So sometimes we write it as Fs max, or limiting friction can also be written as F with capital L. L stands for limiting. So F with capital L is observed to be directly proportional to R. What is this R? It is the normal offered by the surface of contact. So what I'm trying to say is, if there is an object of mass m, and here the reaction force is capital R, and let's say that the limiting friction symbol, it is written as mu s into R, where this mu s is what is called as the coefficient of static friction. Is that point clear? So this is going to be the mathematical formula for limiting friction. So FL will be equal to mu s into R, where mu s is called as the coefficient of limiting friction, and R is going to be the coefficient. What did I say? Okay, coefficient of static friction, and R is going to be the reaction force. That is the normal reaction force offered by the surface of contact. Is the point clear? So make a note of it. Just make a quick note. Done with this? Done. Yeah.
Sir, the third point,
Mhm.
it says as long as normal reaction remains the same. So in slope, it matters.
So as long as this value of R is going to be the same, the value of limiting friction is independent of the area of contact.
No, sir, I'm asking if
That
it
is
is within a slope, does the area of surface in contact matter?
surface, no? Yeah, the limiting friction will be the same still. So if you have a horizontal surface which has a limiting, it's going to be the same. Because limiting friction is because of the nature of the surface. It has nothing to do about the inclination. Try to understand that point.
Okay, sir, okay.
Okay. Shall I proceed? So the next point that we need to understand is what are the laws of kinetic friction, right? Before we go into that, we'll try to understand what kinetic friction is in the first place, right? Now tell me, if we think of the story which we discussed previously, there is an object of mass m that is present here. There is a force. So the limiting friction that can be offered by this rough surface is going to be 5 Newton, right? You kept increasing the force from 1 to 5. Till then, what happened? Did the object move? You started with 1 Newton. Did the object move? No. 2. Did it move? 3, 4, 5. It didn't move. But when did it start moving? 5.000001. It started moving. So when it started moving, the next important question is, this 5 Newton is there? No. Is the friction that is first question, is there going to be friction still existing on the surface? So this object, after the value greater than 5 Newton, has got into what? Has got into motion. Now the question is this surface at the bottom still going to experience force? Is it still going to experience friction? Right? But the question is it going to experience a friction value which is going to be exactly 5, greater than 5, or less than 5? So how many of you say exactly 5? Okay. So how many of you say greater than 5? Less than 5? Others have no opinion? Okay. So it should not be 5, it will be less than 5. Because what is that 5? That 5 Newton is able to come into picture till the object is actually going into motion. If you revisit to the concept of why is friction even coming into picture, what is the answer to that? It is because there is interlocking taking place. So when the object is at rest, there is a possibility of interlocking to be of a greater extent compared to an object in motion. So when the object is in motion, what will happen is the time that is going to exist for the interlocking to take place will be less compared to when it is at rest. Are you able to understand? So there will still be friction that is going to exist, but this time the friction is not going to be limiting friction, rather it is going to be kinetic friction. So what is that kinetic friction called as? The friction that comes into play when the object is in motion. Is the point clear? So this capital F, and there is going to what is called as kinetic friction, and it is represented by the symbol Fk. So what is going to be the logic? Fk is going to be definitely less than the limiting friction, no doubt in that. Because limiting is going to be the maximum friction that can be offered by the surface, even to put or stop the motion, stop the object from moving. I repeat it. So limiting friction is the maximum frictional force that can be offered by a surface to stop it from moving. So kinetic friction should be lesser than that. Having said that, what are all the laws of kinetic friction that are going to exist? First thing is, kinetic friction also opposes the relative motion and has a constant value, and it depends on what? It depends on the nature of the two surfaces that are in contact. Second, the value of kinetic friction, Fk, right? It is also independent of the area of contact as long as the normal reaction remains the same. Third, the kinetic friction, because kinetic friction is different from kinetic energy. So kinetic energy depends on velocity. Kinetic friction does not depend on the velocity, provided the velocity is neither too large nor too small. Okay. And the last important point that you need to make a note is the value of kinetic friction, that is Fk, if you observe, it is directly proportional to the normal reaction between the surfaces. So this scenario also is going to be Fk is directly proportional to R, and Fk is going to be equal to mu k into R, where mu k is going to be the coefficient of name, the subscript is suggested, K. Yes. So mu k is going to be the coefficient of kinetic friction. Are you able to understand? Right? So these are all the laws of kinetic friction. So make a note of it. Make it fast. Shall I proceed? Okay. So going forward, we have you're copying us. Okay. Actually, you can leave some space and copy it later. Listen. So next topic we'll discuss is angle of friction, which is represented by the symbol. You can take lambda. Okay. So if you observe, let's say there is a surface on which there is an object that is kept. Right. So for this object, there is a normal reaction. I'll use N here, for which there is a normal reaction. And there is, let's say, a friction that is acting in the leftward direction. Is the point clear? So are you able to understand these two? So whenever you place an object on a surface, rough surface, there are going to be two things. One is the normal and the second is friction, right? Provided you're going to apply some force in the rightward direction in this case. Now, what is this angle of friction all about? The angle of friction may be defined as the angle, obviously, between whom? Between of the limiting friction and the normal. Listen to this carefully. It will be slightly confusing. Listen to this carefully. It is the angle which is existing between the resultant of the limiting friction and the normal reaction with the normal reaction itself. Meaning, let's try to break it into two parts. Resultant of the limiting friction and normal reaction. This is the first part. So this is the normal reaction. This is the limiting friction. So the resultant of these two, according to parallelogram law of vectors, will be like this. Am I clear? So let me call this resultant as R. So don't get confused. This R is not the same as N. This is the resultant R. So what is the definition telling? It is defined as the angle which is existing between the resultant of the limiting friction and the normal reaction. That resultant should make with the normal reaction itself, meaning this angle. Are you able to understand? Right? So the angle between the resultant of normal and friction and the normal itself is what is called as angle of friction. Now the question is, what is the value of it? I told you it's a derivation, but it's just two steps. So we know that limiting friction is equal to μs times the normal reaction. Am I right? Okay. Now, if you look at the diagram that is existing, if I draw the vector diagram separately, this is going to be FL, this is going to be normal, this is R, and this angle is going to be lambda. Remember, whenever you have two perpendicular vectors, you can define tan of an angle. In this case, I'm defining tan of lambda. Tan lambda will be equal to the vector which is opposite to angle lambda. So what is the vector which is opposite to angle lambda, which does not include, that is FL, divided by the vector which is adjacent to that angle lambda, which is N. So did you understand? Tan lambda is equal to the vector opposite to it and divided by the vector which is adjacent to it. So FL is going to be equal to μs into N, the whole divided by N. N and N will get cancelled. Answer will be μs, which implies tan lambda is equal to μs, or we can say lambda is equal to tan inverse of μs. So this is going to be the mathematical expression for the angle of friction. Is it clear? So this is a very simple derivation. All that you need to understand is the definition, draw the right diagram, take out the vector formula. Okay. So just make You're done with it, let me know. Write down the next heading as angle of repose. Okay. Right. So listen to this. For the topic is called as angle of the cursor there. Yeah. So topic is going to be angle of repose. So what does it state? It states it is a minimum angle that an inclined plane. It is a minimum angle that an inclined plane makes with the horizontal when an object placed on it just begins to slide down. Right. So it is a minimum angle made by the inclined plane with whom? With the horizontal. Till what point? Just before the object starts sliding down. Okay. Let's take this as an example. Observe. Let's take this as an example. I'm keeping my phone here. Right? You're able to observe? So when I draw it diagrammatically, it is like this. On this surface, there is an object of mass m that is kept. So you're actually seeing from this side. So this is the horizontal surface and this is the mass. So horizontal surface and the mass. Makes sense? Right. Question is, listen, if I keep it like this, is it moving? Obviously not. But what I can do is I can start bending it like this. Is it moving? No, no. You're able to see that started the motion, right? So there is one particular angle where this inclined plane is making with respect to the horizontal at which the object starts to move. That minimum angle is what is called as the angle of repose. Can we observe it again? Observe. This is angle of repose. More than, right? So for this surface, it is like this. If you try to place another book or you try to place a smooth surface and see, right, it will be lesser, right? And why is it happening? Because I'm able to see some irregularities here and here. Maybe we'll try to do the same activity by removing the cover. For now, protection. Okay. So previously, this was there, right? Which was creating some amount of interlocking between this surface and the there was an interlocking that is existing between the surface and the inclined plane. Now I removed it. It is smooth enough. I'm able to touch and see, right? So what do you think? The angle of repose will be greater or lesser? In the previous case, I had to open it maybe till this extent, right? Now it started moving faster. Why? The same mass, almost the same mass, right? Except this one. If I ignore the mass of it, it is because of the interlocking that is taking place. Are you able to get a validation to it? Right? It is more important that the surfaces should get interlocked. So if the interlocking is more, then the angle of repose will also be more. Clear? So having said that, let's try to derive a mathematical formula for it. Now listen. So let's say this is the angle at which the object just starts to slide. Okay. So if I place a mass here, right, one thing that you need to remember is the surface is supposed to be rough. If not, you cannot define the concept of angle of repose. Okay. So when it is like this, tell me what are all the forces that will actually try to put the object into motion? mg is acting downwards and mg sin alpha is acting this side. Similarly, mg cos alpha is acting this side. There is a normal force acting this side and there is a friction acting this side. So what friction is it going to be? It is still going to be limiting friction, because what are we saying? The angle should be in such a way that angle should be taken into consideration just before the object starts sliding. So just before the object starts sliding, it is still at rest. So what force will come into picture when the object is at rest? It is a limiting friction. That is why you should take FL. Okay. So if I take the limiting values into consideration, if I take the limiting values into consideration, tell me just before the object starts sliding, which two forces along the inclined plane will get balanced?
Both.
So along
Both were-
inclined plane,
Worked out. Showed
which two forces are balanced? Can you tell me?
I think only more.
mg sin alpha is balanced by limiting friction. Makes sense? Right.
Henry.
This is equation number 1. Okay, let's extend it more.
Okay, are you following this one?
So
Both.
this is going to be equal to
So you go through that. If you have any
mu
doubt,
s
just you can ask me.
into,
You go through your textbook.
normal.
Textbook, if anything is.
so Fl is equal to mu s into normal.
You cannot follow.
So let me call this as equation number 1. If you observe, the object is moving only along the inclined plane, whereas along the vertical, along the side perpendicular to the surface, is it moving? So what about this force and this force? What about the normal and mg cos alpha? They are balanced in the sense n will be equal to mg cos alpha. Let me take this as 2, take this and substitute it here. When you do this, you will get mg sin alpha is equal to mu s into mg cos alpha. Mg and mg are gone. So sin alpha, cos alpha will come this side. Tan alpha is equal to, which implies alpha is equal to
Performance
tan inverse of.
theory. Definitely. Law of dominance.
So the angle of repose is also
Law
going
of
to have the same
segregation.
mathematical expression,
Law of
like
independent.
that of angle of friction.
That's the main thing you should know.
Am I clear with this? So this is the simplest derivation that you have for this angle of repose, which is represented by the symbol alpha. I hope I'm clear, right? So make a note of.
Lakshmi, are you there online? Hello, Vijay Lakshmi, are you there? And if you have anything to ask, you can ask. Any doubt, any clarification, if required, you can ask. I cannot hear anything from you, but check to that.
So let me know once you're done with this. You're done? Okay. So there is a problem. Solve this. A block of mass 2 kg is placed on the floor. The coefficient of static friction is 0.4. The force of friction of 2.5 Newton is applied. Sorry, as shown in the figure. Calculate the force of friction. I think this force of friction is wrong. It is force of 2.5 Newton is applied on the block as shown in the figure. Calculate the force of friction between the block and the floor. So what is the answer? We have only one formula for frictional force. Did you take down the values? So keep trying it. Tell me what is the answer. 2 minutes time. Let's see how many of you understood the concept.
Well done.
Answer? Yeah, Aniruddha, tell me.
1 minute, 1 minute.
Sorry, I didn't get you.
Was it 2.5 Newton or 2.4?
2.5? Answer is 2.5.
Yes, sir.
How? How is it 2.5?
Sir, I did mu mg, so 0.4 into 2 into 10, I did.
Okay.
Yeah, I got answer as 8 Newton.
Okay.
So the object was remain at rest. So
That's right. So anyone else who got the answer for this? It's actually a simple problem. Okay, listen to this. There is a block of mass 2 kilogram which is placed on a floor. The coefficient of static friction is 0.4. So mu s is equal to 0.4. A force of 2.5 Newton is applied on a block as shown in the figure. So force of how much value is applied? 2.5 Newton is applied on the block. Now the question is, calculate the force of friction between the block and the floor. Okay, can you tell me what is going to be the limiting value here? Limiting value is equal to mu s into n. So what is the normal force in this case? It is mg. 2 is the mass. Normal force is mg. Right? So mu s is going to be how much? 0.4 into what is the value of m? 2 into g, I'll take it as 10. Okay. So this is going to come out as 8 Newton. So the limiting friction that can be offered by the surface is 8 Newton. But what is the force that we applied? It is 2.5. So if you write the answer as 8, you're wrong. Because limiting the static friction is self-adjusting in nature. Means if you apply 2.5 Newton here, out of this 8, only 2.5 will come into picture. So in this case, the frictional force, they ask calculate the force of friction between the block and the floor. No, that friction is actually the static friction that they are asking. What is the static friction? It will be 2.5 Newton. Is the point clear? Am I clear or not? Yes? Yeah. So who told the answer online? Sorry, Rahul Mishra. Now speak.
as well.
Ah, okay. Right. So try this problem. Read the question carefully. They're saying tension key T which can be increased to 8 Newton before the object starts sliding. So what is the meaning of it? Indirectly, they've given you something.
Static force.
They have given you the limiting value. Limiting is 8 Newton. Means they are trying to say minimum force of 8 Newton needs to be applied before it starts moving. That is after the object has started moving. Correct. So I told you, limiting friction is always greater than the kinetic friction. So there's a hidden information in that. I hope you could understand. So just to conclude, what are all the values that are given? Weight of the object is 20 Newton. Why is weight given in this problem? Is it important for us for finding the
Right. Got the answer.
normal? Yeah. Those who are online. Yeah, tell me. What is the answer?
0.4 is the coefficient of static and 0.2 is the coefficient of kinetic.
Static one is 0.4.
4.
Correct.
And kinetic is 0.2.
Kinetic is
0.2.
correct. It's actually a simple problem. You can do it in 2 steps. All that you need to do is understand the question. Since they have given, it's a weight. That's why it's weight. It's not mass. No need. Newton is given, no? So the question says, a block of weight 20 Newton is placed on a horizontal table and a tension T, which can be increased to 8 Newton before the block begins to slide. That is actually the direct definition of limiting friction. So limiting friction in this case is how much? 8 Newton. What is the weight of the object? So weight is 20 Newton. So what is going to be the normal reaction? That is also 20 Newton. Right? So since you know the limiting friction, first point is we need to find the coefficient of static friction. Let's concentrate on that. So for static friction, FL will be equal to mu s into N. What is the value of FL? 8. 8 is equal to mu s is what you need to find. And what is going to be the normal reaction? It is 20. So what is going to be the value of mu s? It will be 0.4 and it is a dimensionless quantity. No units for it. Okay. Similarly, this is the first part of the question. For the second part, if you look at the second part, a force of 4 Newton is sufficient to keep the object in motion with constant speed. Meaning, if this force is 4 Newton, listen to this carefully, okay? I'm going to introduce a term. If this force is 4 Newton, they are saying that the kinetic friction is also 4 Newton, right? Where the object is going to be in motion with uniform velocity. Means this kind of a balanced situation, listen to this carefully, this kind of a balanced situation where the object is in motion, but there is no acceleration. Why did I say there is no acceleration? So if the system is still in motion without acceleration, you call it as equilibrium, and more specifically, you call it as dynamic equilibrium. It is called as dynamic equilibrium. We call it as dynamic equilibrium because dynamic means it is in motion, but still the forces are balanced. Equilibrium means forces are balanced. One misconception people have is they think that equilibrium means the object should always be at rest, not necessary. So whenever you say equilibrium, the object should not have acceleration. So when acceleration 0, the object can either be at rest or in uniform motion also. So if the equilibrium is attained by the object being at rest, you call it as static equilibrium. Okay. If the equilibrium is attained by the object being in uniform motion, you call it as dynamic equilibrium. That is why this is a situation of dynamic equilibrium, where this 4 Newton force that you are actually applying is exactly equal to the kinetic friction. So Fk itself is 4. So we know that Fk is equal to mu k into n. What is Fk? 4 is equal to mu k is what we need to find into n is how much? 20. So 4 divided by 20 is going to give us 0.2. And if you observe these values, right, there are two important takeaways from this problem. One is the limiting friction is always greater than the kinetic friction. Suppose in the problem they had mentioned a value greater than 8, no, when the object is in motion, the question itself is wrong. It's not possible. Because once the object has started moving, you can apply less amount of force to it. Okay. Are you able to understand this point? Similarly, whenever you get a result, the coefficient of static friction should always be greater than the coefficient of kinetic friction. So here it is 0.4, here it is 0.2. We are right. Okay. There is a possibility of V being right, but yeah, calculations part you need to be careful with. Is the point clear? Yes. So make a note of it. Okay. On that, I have to take another question. So this is a very simple one. So I'm trying to give all the problems based on the concepts we discussed. Okay, just read it. You will get the answer in one step. You need not solve also. So here it is 1 divided by √3. So what is the answer? That's the answer. That's it. Told you, no? So you need not solve it. What is the question? It says there is a cubicle. Yeah. It says there is a cubical block that rests on an inclined plane of mu is equal to 1 by √3. But here, if you observe, they didn't give you what value of mu is it. Is it static? Is it coefficient of static friction or kinetic friction? They told mu, no. They didn't say whether it is coefficient of static friction or kinetic friction. The hint is given in the question itself. Rest. So what is the force that is going to come into picture? So it is going to be the coefficient of static friction only, because it is still at rest, right? So this is mu s, right? Determine the angle of inclination when the block just slides down the inclined plane. So what is that value called as? Alpha is equal to tan inverse of, if you observe the formula, it is not tan inverse of mu where you can substitute anything you want. It is always tan inverse of mu s. So that is why you need to be specific. And what is that angle at which the object just starts to slide called as? It is the angle of repose. It is angle of repose. Okay. So this will be tan inverse of 1 divided by √3. What value is this? It is going to be 30 degrees. So for this surface, exactly at an angle of 30 degrees with the horizontal, it will start sliding. Is the point clear? Right? Okay. So these are all the basic concepts related to friction. The last part that is left in the chapter is its applications, where there are two applications. One is how friction comes into play when when a car is moving in a circular track, a horizontal circular track, and something called as banking of roads. So these two are there, which are important. Okay. With that, this chapter is done. Okay, that will complete it tomorrow. Any other questions from today's class? Is it clear? Okay. So first 15 minutes tomorrow, I want to test your basics of what we discussed today. Not only today, I'll actually make it half an hour because I want to see how your free body diagrams are. Banking lam puriyadilla. So tomorrow's class, first half an hour, I'll test free body diagrams and the concepts we discussed today. Is that point clear? Okay, practice and come. Okay, there are no questions, we can wind up. Those are online, any questions?
Yes, sir.
Okay. So we can start the math class around 6:10. Okay. Can also take 10 minutes break and come.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.